Hello learners, welcome to the second lecture of this course, that is Basics of Quantum Mechanics. In the first lecture, we learn about the physics that demands the development of quantum mechanics. In this lecture, we learn about the particle nature of wave, that is the origin of quantum mechanics. Before that, let us discuss the black body radiation spectrum, which is actually the building block for the development of quantum mechanics. A black body, as you all know, black body is a body that have 100% emissivity and 100% absorptivity. Coal have maximum emissivity and absorptivity around 95%, and none of the naturally occurring body behave like a perfect black body. As the picture shows, perfectly black body can be made artificially. For that, we need to take a metallic ball. Over the surface of that metallic ball, if we did a pinhole and make the inner surface of this metallic ball reflecting, then whatever be the radiation fall over this pinhole, it will get absorbed due to the multiple reflections inside the cavity as shown in figure. Means the radiation will be get absorbed by the pinhole, whatever be the frequency or the intensity or the wavelength of incident radiation. That is, this pinhole is actually serving as a perfect black body. When this ball is allowed to set at a certain temperature, the radiation will emit through this pinhole, and if we plot this radiation, emitted radiation through this pinhole or through this artificial perfect black body, if we plot this radiation as a function of wavelength, this radiation will comes out to be something like this. From this graph, certain conclusion may be done. The first one is that, which can be explained with the help of the Stephen Boltzmann law, which says that the larger be the temperature of a body, larger be the energy emitted from that body. This graph is also satisfy this equation. As you can see, as the temperature increases, the area under the curve increases. That means larger be the temperature of the black body, larger be the radiation emitting from the body. Wiens also tried to explain the nature of this curve. He did some mathematical manipulation in the Stephen-Boltzmann law and came across this expression. And if we plot this equation, if we plot this expression, then this equation satisfies the first half of the curve, that is low wavelength region. Means as the wavelength increases at a certain temperature, the intensity or the radiation emitting through the perfectly black body will increases and it reaches to a peak value. Wiens also try to find out this peak value, and he come out to be to this expression, that is lambda t is equals to constant. This expression justify that as the temperature increases, the wavelength corresponding to the maximum energy decreases, which can be seen by this blue line of the from this graph. Rayleigh-Jeans also try to explain this curve, and he proposed the physics behind the emission of radiation from the artificial black body. He said that when the body is set at a certain temperature, the formation of harmonic oscillator of all possible energy inside the cavity is possible, and due to which the radiation is emitting from the pinhole. And the energy associated with this harmonic oscillator is continuous, that is all possible energy harmonic oscillator is possible inside the cavity. With the help of this Rayleigh-Jeans law, the second half of the curve can be explained. As the temperature, at a certain temperature, as the wavelength increases, the energy emitting through from the black body decreases. Or if we extrapolate this graph, it can be shown from this curve that the possibility of ultraviolet catastrophe is there, which is practically not possible. That means this Rayleigh-Jeans law need to be terminated, or the graph need to be terminated as proposed by the Rayleigh-Jeans law somewhere at the peak value. This was possible with the help of theory proposed by the Planck. Planck said that the concept of harmonic oscillator as proposed by Rayleigh Jeans is uh, acceptable, but the energy or associated with these harmonic oscillators are not continuous, while this is discrete. That means a minimum amount of energy is there, and total energy is always the integral multiple of that minimum amount of energy. Planck says that that minimum amount of energy is termed as quanta or the photon, and he find out he come across this expression which is Planck's law for the explanation of black body radiation, and by as a particular case of this expression Planck's law, we can come across the Rabin's law and Rayleigh-Jeans law separately. That means the complete nature of the graph is possible to be explained. The second most famous effect which demand the origin of quantum mechanics was photoelectric effect. As we all know, whenever a metallic surface is allowed to is exposed for a radiation, it emit electron from its surface. If the intensity, if the frequency of the incident radiation is beyond a certain limit, and this electron can be captured with the negative potential and can be served as a current. And this is the graph of photoelectric effect. That means there is a threshold frequency beyond which the energetic electron can be received, and below which no electron will emerge out from the surface of the curve. As the picture shows, the red color photon or red color radiation is not capable to emit electron from the potassium surface, because the work function of the potassium surface is 2.0 electron volt, while the energy corresponding to this red color photon is 7.7 electron volt, which is less than 2.01. That's why this is the red color photon is not capable to emerge electron from the surface of the metal of the potassium metal, while green color and blue color is possible, and the emitting electron will also have a certain frequency, a certain velocity, and larger be the energy of the incident photon, larger be the velocity of the emitting electron. This curve was successfully explained by Einstein in 1905, and he also got Nobel Prize in 1911 to 1911 for the successful explanation of photoelectric effect. And this is the curve which from which we can see, as the intensity, as the frequency changes, the stopic potential decreases, and the energy of the incident photon can be seen from this curve. The third most famous concept that support the uh, particle nature of wave was the Compton effect. Quite interesting, proposed by Compton. Quite interesting concept. It says that when a radiation is allowed to fall over a electron or a microscopic particle, the microscopic particle get recoil, and the radiation get reflect. And if we and the wavelength of reflected radiation was larger as compared to the incident photon, or the energy of the reflected radiation was less as compared to the incident photon. This can also be explained if we consider this radiation as a photon or as a particle, and we assume that the collision of this particle with the electron in rest is the elastic collision, and by applying the concept of conservation of energy and conservation of momentum, we can come across this expression, that is delta lambda is equals to h upon mec 1 minus cos theta, which is called as Compton shift. This is interesting to note that in this expression, the shift is the shift in wavelength, that is delta lambda, is totally independent to the intensity of the incident radiation or the frequency of the incident radiation. It only depends on the angle of reflection. Means we can have a various intensity or the various frequencies at different angles with the help of this concept.